Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about factorials and permutations for counting. Let's look at an example question here. Suppose 8 people run in a race. There's no ties, right? So we're just thinking about a normal race, kind of. And we want to first ask how many different outcomes of the race are there. Now, one of the things in counting questions, you need to interpret what this might be asking a little bit. So if we're talking about outcomes, we probably want to know what places people got, right? Who gets first place, then who gets second place, third place, etc. And even just that obvious, in a sense, observation gives us a method for counting. Well, how many ways can we choose who gets first place, right? One of the 8 people running in the race will get first. Now there are 7 remaining people. One of the 7 people will get second. One of the 6 people will get third, right? And this keeps going down. 6, 5, 4, 3, 2, 1. And then we have answered the question. Now, you might notice here a little bit, this is a little bit annoying to write out, right? It's a nice pattern, the number keeps going down by 1, and we want to be multiplying. Well, this is exactly where new notation comes in. This is exactly where a factorial comes in. So we could write this very easily as 8 factorial, and if you calculate this, you will get 40,320. So there are quite a few outcomes, even if we just have 8 people running in this race. Now, let's do a slightly modified version. What happens if we only want to worry about gold, silver, and bronze medals? Now, if we think about this a little bit, this is really telling us we only care about the first, second, and third place outcomes. So if we actually just think exactly as we did before, we can come up with, okay, 8 people could be given the gold, 7 people could be given the silver, and 6 people could be chosen for the bronze, right? And then we have this kind of written out that way as well. One of the patterns we want to develop, though, too, is how we could write this in terms of factorials. It isn't, of course, the full 8 factorial, because that has a 8, 7, 6, 5, 4, 3, 2, 1. So we need to divide by 5 factorial to get rid of that denominator that we don't want. Of course, this isn't helpful in this specific example because the numbers are small enough anyway, but it helps us kind of find a pattern. If you are curious about the actual answer, then here it is 336. So we had 40,320 outcomes in total, and if we only look at the first 3 people, we had 336. Looking at these then in terms of a general formula, right? So if we have k different objects, they're chosen in a particular order from a collection of n total objects. We want to know how many ways this can happen. Well, we're doing the same exact idea. You have a first object, there are n choices, right? Then a second, a third, all the way up to a kth. So just writing this out in the formula, we can just see it nicely typed out here. You have n choices for that first object, right? Then you have n minus 1 for the second object, all the way down to the kth object. This goes down to n minus k plus 1. But really, the kind of nicer way of looking at this is with the factorials. You can write this pretty nicely as n factorial, and you have all of n factorial except, right, you have to get rid of the other n minus k of them. We only want the first k objects. So this is a pretty nice way of coming up with this idea of a permutation, right? This here is our permutation that we are talking about for choosing an objects with a particular order. Okay, thank you guys for watching this video. Check back each week for new math tidbits, and hopefully I'll see you guys on the ZIML site and our other YouTube videos for more practice as well. Goodbye.